All right, guys, let's go ahead and start. Hopefully, in a little bit. Okay, let's just get this started. Sorry. All right, here we go. First question. It says, "What is the approximate instantaneous rate of change for the given function, pi over 9?" So that just means take a derivative. So just take a derivative of this guy, and then so I'm going to go f prime of x or t. It doesn't matter. Well, I guess that says t, so I should probably f prime of t. F prime of t equals, and then I notice that I have a 16 on the top. Perfect. So that's what you got to have. You got to have a variable on the top and a constant on the bottom of the your integrand here. So the derivative is going to be cosine of 6t times the derivative of 6t, which is just 6. And then we just plug in a pi over 9. You're probably going to need a calculator, but this one you don't need a calculator for. 6 cosine times 6 times pi over 9. And then I can simplify that to 6 times cosine. Let's see, 3 goes into 6 twice. So 2 pi over 3. And then 3 goes into 9 3 times. So cosine of 2 pi over 3 is a negative half from the unit circle. 2 pi over 3 right there. And then at that coordinate, negative half, comma, square root of 3 over 2. So your so cosine of 2 pi over 3 is negative half times 6, that's a negative 3. More than likely, you're probably going to need a calculator because I'm looking at all these digits here. So, well, maybe that one, not necessarily, but... Alright, here we go, guys. Approximate the smallest value of c that satisfies the mean value theorem for derivatives for the given function of the interval 0 to 3. Okay, so here's my interval, and they want me to apply mean value theorem. If you don't know mean value theorem, all it means is that your instantaneous rate of change is equal to your average rate of change. That's all it means. Let me change this here. So, find your average rate of change. Type this into y1. So let me do that really quick. And then I'm just going to tell the calculator to give me the average rate of change. So I'm just going to go y1 of 3 minus y1 of 0, all divided by 3 minus 0, or divided by 3. And I get, let's see, y1 of 3 minus y1 of 0 divided by 3. I get 2.22615. I'm using a T89, so I have it to float 4 or float 5, so it gave me 5 digits after the decimal. So now what you're going to do, I'm going to go to y2, and I'm not going to bother taking a derivative. I mean, if you want to do it by hand, go for it, guys. Product rule with chain rule, and then that's just, if you want to just take a derivative, it doesn't look like it would take too long. But I'm just going to go to y2 and I'm going to go ddx of y1 at x equals x. If you're at 1084, that's how you're going to insert it. And on y3, I'm just going to put in this value right here. 2.22615. I have a TI-89, so you're going to have to type in ddx of y1 of x. And that will do it. But if you have a TI-84, you're going to have to type it in like this. So type in your derivative on y2. And on y3, type in your average rate of change, and then just find where they intersect. Find where these intersect. So that's how you're doing. See, you're doing the left side here. The left side is your derivative. So what does the derivative equal? 2.22615. So let's do that really quick. F5, F5 intersect. First curve, second curve, lower bound, upper bound. If you have a T84, you're not going to have so many, you're not going to be pushing so many buttons. Okay, so I got a C value, or X of C value of 0.057606. Notice that all the X values are small, guys. 0.05. So when you make your window, just hover, make a window where you're hovering, x min 0, x max 0.01, not 0.01, 0.1 because of that guy, or maybe make it 0.2, and then just hover, since this is 2.22615, so just hover around it, y min 2, y max 2.5, and then just see where it intersects. All right. Use the table below and the trapezoid method with n equals 5. All right, so I see if n equals 5 between 0 and 2, that means each trapezoid, there's 1, there's 2, there's 3, there's 4, there's 5. Each trapezoid has a height of 0.4. And then this is going to be my base 1, base 2, base 3, base 4, base 5, base 6. You're going to need 6 points if you're going to have 5 trapezoids. So I'm just going to use the formula, guys. So let's see, h divided by 2. So my height is 0.4. So 0.4 divided by 2. And then I'm going to use these points. The last two do not have a 2 in the front. So I'm going to go 4.4 plus 2 times 4.1 plus 2 times 4.3 plus 2 times 4.2 plus 2 times 3.9 plus 3.8. So do that. And I'm pretty sure you guys can handle that, so I'm not going to go ahead and figure that out. But do that, and you'll get your answer from there, guys. If you have any questions, leave it in the comments, and I'll try to get to it. All right, let's go to the next one. The value of h greater than or equal to 1 increases at a rate that guarantees the area between the graph of y equals f of x on the x-axis between 0 and h increases at a rate of 3 square units per second. Give dh dt when h equals 4. 3 square units per second. So that is my area. The value of h increases at a rate that guarantees the area between the graph of y equals f of x and the x-axis. H increases at a rate of 3 square units per second. So I see dA dt is 3. Give dH dt when h is 4. Alright, so let's see here. They want dH dt, and when h is 4, the value of h greater than or equal to 1 increases at a rate that guarantees the area between the graph of y equals f of x and the x-axis. Alright, so the area is equal to the integral between 0 and h of f of x dx. So this is my area formula. At a rate of 3 square units per dH dt when give dH dt when h equals 4. Okay, so here we go. I'm going to take a derivative, and when I take the derivative, I'm taking it with respect to time. So I got to make sure that I have a variable on the top of that integral and a constant on the bottom. I do. So here we go. dA dt is equal to f of t times, I'm just using the fundamental theorem of calculus, guys. I'm taking the derivative of an integral times the derivative of h, but I'm doing it with respect to t. So times dH dt. So there it is. They want to know when h equals 4. So I'm going to plug in f of 4 times dH dt. I don't know what that is, but I do know what dA dt is. dA dt is 3. So there it is. So I'm going to type it in and let's see what I get. So 3 equals, let's see, 1 over 4 to the 4th plus 1 times dH dt. So I get, let's see, 1 divided by 4 to the 4th plus 1. So I get 3 equals 1 over 257 times dH dt. So to get dH dt by itself, it's obvious you got to multiply by 257 both sides. So dH dt is equal to 3 times 257. So let's see what that is. 3 times 257. 771. There it is, guys. So make sure you understand the concepts. As you saw, I had to reread it 3 times just to understand what was going on. So please take your time, read it, reread it, and then once you have an idea of what's going on, you can go from there. So make sure, don't become a robot. Understand the concept, and you'll be fine. Here we go, guys. Question 5. Let R be the region in the first quadrant bounded by the graph of 16 minus x squared and the coordinate axis. So that axis, not axis, sorry. That means that it's the x and y axis. Determine the value of k such that y equals kx squared separates R into two regions of equal area. All right, so first you gotta find the area of 16 minus x squared between 0 and 4. So that's what we're gonna do first. Not drawn to scale. Here's 4, that's supposed to be 16 up there. That's the first part, this is the first region here. So integral from 0 to 4 of 16 minus x squared dx is going to equal to, and I just did it a little while ago, 128 over 3. So then I have this other region, kx squared, that's going to do something like this. And that value there, well, this graph is y equals kx squared. So we need to figure out where they intersect. So obviously here's region 1, region 2. It splits it up into two equal areas, so that's 128 over 3 times 2, so 128 over 6, which reduces it to 64 over 3. Alright, so let's figure out where these intersect. So they have the same y value, so I'm going to make 16 minus x squared equal to kx squared. 16 minus x squared equal to kx squared. I'm going to move the x squared to the right. 16 equals kx squared plus x squared. Let me know if you find any errors, guys. I'm going to factor out an x squared. K plus 1. I'm going to divide by k plus 1. And I'm going to take the square root. You don't have to worry about plus or minus because we're only in quadrant 1. So x equals 4 over square root of k plus 1. That's where they intersect. So I'm going to, this is some x value. That's this x value here. See? So here we go, guys. Integral from 0 to 4 over square root of k plus 1 of what function? Upper minus lower. So 16 minus x squared minus kx squared dx. See? Upper minus lower. You can't do the other one, guys, because then we'd have to split it up into maybe two integrands. See, so kx squared between 0 and 4 over square root of k plus 1, and then you got to do the 16 minus x squared from 4 over square root of x plus 1 to 4. And why complicate things? I think this is the easier route. I think. We'll see. All right, let's go ahead and do the antiderivative. I'm going to do it in green, guys. So I'm going to go 16x minus x cubed over 3 minus kx cubed over 3. All this is going to be evaluated from 0 to 4 over square root of k plus 1. And I'm just going to put the 4 over square root of k plus 1 into my calculator. I have a TI-89. You can put it into Wolfram Alpha. And I'm just going to set it to solve for k. So here's what I'm going to do. If I plug in a 0, you get 0 for everything. So here we go. 16 times 4 over square root of k plus 1 minus, let's see, 4 over square root of k plus 1, close it to the third power, divided by 3, minus k times 4 over square root of k plus 1, close it to the third power, all divided by 3, and all this better equal 64 over 3. So you can either type this into y1 and type this into y2, which maybe I would do, and put your x values from 0 to 5. The k, type it in an x. I have a TI-89, guys. I'm just going to type it in the way I see it there. So let's see. Hopefully it doesn't take me too long to type it out. Algebra, solve, 16 times parenthesis, 4 divided by open parenthesis, square root, x plus 1, close, minus, open parenthesis, 4 divided by open again, square root, x plus 1, close, x plus 1, close, that closes that one, that closes that one, Another one, right? To the third power, all that divided by 3 minus x times, open parenthesis, 4 divided by open parenthesis again, square root of x plus 1, close to the third power, all that divided by 3 equals 64 over 3, comma x. Let's see if I typed it in correctly. Oh, my calculator is calculating it, guys. Come on, buddy. $3.00000001. Okay. 3. I would just type it into the TI-84. I would type this into Y1. Let me circle it for you here. I would type this into Y1, and I would type this into Y2, and then just see where they intersect, guys. Cool? Cool. Oh, man. What happened there? Okay. All right, here we go. Next one. All right, guys. Sorry, guys, for the delay. I was hanging out with my parents, eating and all that good stuff because, I love food, and my parents are pretty cool. But yeah. All right, let's go ahead and continue. I actually first let me make sure I'm recording because I have done a whole bunch of problems before and then it didn't record at all. So yeah, I'm recording. Yay. All right, here we go, guys. The first thing I would do, I'm looking at it, and you can't do u sub because if I say that u is x squared plus 6x plus 12, then du is going to be 2x plus 6, and I don't see how you can plug in the 2x plus 6 anywhere. So these ln's are automatically out. They're the worst ones. It's going to have to be one of these arctans. Now, I think this one is a bug on it because I just typed this into my TI-89 to give me an answer choice, and I don't see any one of these that are equivalent to the answer choice that I got. But I'll show you what I mean. All right, first thing I would do, we're going to have to do something called complete the square. So you take your x squared plus 6x plus 12, and I'm going to put the plus 12 way over here on the side. And what I do is I take that 6 and divide it by 2, which is 3, and when you square that is 9. So plus 9, and then minus 9 to balance it out. So this right here, these 3, when those reduce to become a perfect square. X plus 3, close it with a square on it, see? X times x is x squared, x times 3 is 3x, and you're going to have 2 of those, so 6x, 3 times 3 is 9. And then the difference between 9 and 12 is 3, so there it is. So what I really have is the integral of 1 over x plus 3, close it, squared, plus 3 dx. So this almost looks like arctan, but not quite. So what you got to do is divide everything by 3. So then I have 1/3. So if I had to guess, I would guess C here, but I think this one's buggy. So if you get one of these, let me know, and I'll give you the credit for it. But I got to see this work here. So 1/3 integral 1 over x plus 3 divided by square root of 3 squared plus 1 dx. So if I do my u sub, and I set u equals x plus 3 over square root of 3, then du is going to be 1 over square root of 3 dx. So I do have that. If I move that 3 to a square root of 3 and then 1 over square root of 3. So the 1 over square root of 3 dx is your du. So 1 over square root of 3 integral du over u squared plus 1. And that is arctan, or 1 over u squared plus 1. So 1 over square root of 3 arctan of u, which is x plus 3 over square root of 3, and then plus c. So I don't see that answer in there, guys. Now I'm thinking, maybe you're thinking like, well, Chavez, you got to rationalize it. Okay, times square root of 3 times square root of 3. So maybe my answer should have been square root of 3 over 3 arctan of square root of 3 over 3 with an x plus 3 on the side, like so, plus c. But I still don't see that answer or an equivalent answer. So if you get this question that's a little buggy, let me know and we'll give you the credit for it. If you type this into Wolfram Alpha, you won't get any of these answer choices there. All right, let's continue. Question 7. Suppose that f of 1 equals 3 and that f prime is given below. Find f of 6. All right, so this is pretty straightforward, guys. Pretend f prime is like the velocity and f is like the position. So they want to know the position at 6. So my position at 6 is nothing more than my position at 1 plus the displacement between 1 and 6 of f prime. And that's all you're doing, guys. So I'm not going to insult your intelligence. I know you guys can do that. 3 plus the integral from 1 to 6 of 2 over 3 plus sine 3x. You don't have to type anything by hand. Just do it all in the calculator, and there you go. Sorry, guys. I had something on my nose, and I had to, like, reach in really quick. Sorry, it was TMI. I'll make sure to edit that out. All right, here we go. Next one. A solid ball is made of a composite material, the temperature T in degrees C, at time T hours of the center of the ball satisfies the equation T prime equals blah. If T of 0 is 20 degrees Celsius and T of 40 equals, it's the same as what we just did right now, guys. T of 40 is equal to the initial T of 0 plus how much it changes between 0 and 40 of T prime. T prime of T. So this is going to tell you the change in temperature. How much it changes, not the change. The change in temperature between T equals 0 and T equals 40. And then you just add it to the 20 degrees and you get your answer. So I think you guys can do that one. So let's just keep going. The first derivative of f given below. How many critical numbers does f of x have on the interval 0 to 8? So critical numbers is where f prime of x equals 0 or d and e. So what you do is you type this into your y1 and then just hover, guys. X min 0, x max 8, y min. You want to hover, since you want to count how often it crosses the x-axis, you want to hover around the x-axis. So I'm going to go y min negative point, let's see, kind of close to it, negative 0.5, y max 0.5, and then just count how many times it crosses the x-axis. So let me write that down. Count how many times f prime crosses / touches x-axis. And that's it, guys. All right, let's continue for the sake of time to keep going. The function f is given below is invertible. What is the area between the graph of the inverse function between the y values 0 and 3? All right, so this is talking about the inverse function, guys. So that means these values, 0 and 3, were originally x values on the original. X values on original. So if you want to know the area, all you're going to do is integrate between 0 and 3 of f of x. And I think you guys can do that. So that's it. Yeah, that's it, guys. Let's keep going. Which of the following best describes the behavior of the function f at x equals 5? Okay, I have a slight suspicion, only because I have an x minus 5 here on the top. I have a slight suspicion that something is happening at 5. I'm gonna do division. I'm gonna synthetic division here. So I'm gonna put 5 as one of my zeros, because you know x minus 5 equals 0, so x equals 5. And I'm gonna write 1, negative 12, 48, negative 68, 15. If you want to factor it out, if you have a TI Inspire CAS, you can type this in the denominator verbatim, and you can just tell the calculator to factor it out for you. So I'm going to bring this 1 down. 1 times 5 is 5. The difference between negative 12 and 5, let's say 5, 6, 7, is negative 7. Negative 5 times negative 7 is 35. That took longer than necessary. Negative 35. And the difference between 35 and 48, 35, 45, 16, 48 is 13. And then 5 times 13 is 65. And the difference between 65 and 68, 67, 68 is 3, but negative. And 5 times negative 3 is a negative 15. So I get a 0 here, so that means that my denominator reduces to this. I have an x minus 5, and I have x cubed minus 7x squared plus 13x minus 3. As soon as you get that, I would not bother. You have an x minus 5 in the top. So what's going to cancel out? The x minus 5s. As soon as the x minus 5s cancel out, that means you have a hole at x equals 5. Hole at x equals 5. So it's a removable discontinuity. I'm just going to keep going, guys. The function f given below has a local maximum at negative 2. Find the value of c. Okay, if I have a max at negative 2, that means my derivative is 0 at negative 2 because I look something like this. So that right there at that moment, f prime of that, or whatever c value, is 0. So I'm going to take a derivative. Here we go. I'm going to first rewrite it. X plus c, x is negative 1. So here's my derivative. 1 minus c x to the negative 2. And I'm going to plug in a negative 2. 1 minus c over negative 2 squared. I'm going to equal it to 0. So let's see what I get. I'm going to move this to the right. 1 equals c over 4 times 4 times 4. I get c equals 4. Let's keep going. The region above, y equals 6x. So here's my little sketch. And below 7 sine x. So I'm going to say that's 7 sine x. And region above 6x. So I'm just going to assume that it looks something like this. I'm probably really exaggerating it. Probably looks something more like, let's see, 6x. So I have that little region there, and I'm rotating that region, rotate about the x-axis. Give the volume of the solid generated. So I have something like this, guys. Now I'm exaggerating, but it looks something like that. Looks like Pac-Man a little bit. So you have a washer. So my volume, pi on the outside, find the intersections. One of them's obviously 0. You're going to have to find where they intersect here, guys. So I'm going to have to type in 7 sine x into y1. And on y2, you're going to have to type in 6x. And you're going to have to see where they intersect. So let me try that real quick. 7 sine x and 6x. Clear. And window. It's going, guys. It's just going slow. I should have brought a 1084 with me, but I didn't, unfortunately. Alright, let me find this F5 intersection, first curve, second curve, lower bound 0, upper bound. Oh, it looks like it intersects pretty fast. Alright, let me do that again. First curve, second curve, all bound 0, all bound. Alright, I got some errors here. Okay, sorry guys, sorry. Fast forward if you want. Sorry if I'm torturing you guys here. It's just that I'm not used to this 89 here. Intersection 1, 2, lower bound 0, upper bound. Come on, buddy, hurry up. Five, intersection, first curve, second curve, lower bound there, lower bound there. Okay, finally. Sorry guys. So I got an intersection at x equals 0.946826. So integrate from 0 to 0.946826. Store it to a letter. Maybe store it to A or something, and you can use the letter A. So the big R is the distance from here to this curve. That is first your sine x. So in parentheses, type in, oh, sorry guys, that's my laundry there. 7 sine x, close it squared, minus, it's going to ring again. So sorry if it's really annoying there. 6x, close it squared, dx, and then just, okay, I'll do it for you guys. I was going to say just type it in, but I'll want to try it out just to make sure that I get the answer that's the right one. So let me go to my home screen here and type x of c and see if it prints it out. X of c, perfect. Store that into A, alpha A, and I'm going to try it out here. I'm going to put pi on the outside times my integral here. So pi times integral of 7 sine x close squared 1 2 1 2 minus 6x close squared comma x comma 0 comma alpha a. 4.38. So it's this one right here, 4.36. There's probably some rounding going on, but there it is. All right, let's keep going, guys. The base of a solid is a circle, x squared plus y squared equals 1. Find the volume of the solid given as a cross-section perpendicular to the x-axis is an equilateral triangle. All right, so I have a circle and cross-section perpendicular to the x-axis. So here's my cross-section in green, perpendicular to the x-axis. So I have a triangle coming out of that. And that triangle looks like it's an equilateral triangle. So this right here is that. So let's see. The distance from the top, okay, the top curve is y equals square root 1 minus x squared. And the bottom part is y equals negative square root of 1 minus x squared. And together, from the top all the way to the bottom, that is 2 square root of 1 minus x squared. All right, so I want to find the area, the cross-section area for one of these equilateral triangles. And that is, let's see, that's 60 degrees there. So my area cross-section is, that length here is 2 square root of 1 minus x squared. So that means that length is also the same thing. So 1/2 2 square root of 1 minus x squared times 2 square root of 1 minus x squared times sine 60 degrees. So I'm gonna integrate. So my volume is gonna be the integral from -1 to 1. Let's see if we can reduce this here. 1/2 times 2 is 1, and the square root times the square root is just whatever's on the inside. I still have that 2 there. So 2, 1 minus x squared, and then sine of 60 is square root of 3 over 2. So the 2's cancel out there. So I have a square root of 3 with a 1 minus x squared dx. And you can put the square root of 3 in the front if you want. No big deal. So let's try that out real quick, guys. Integral negative, I gotta type in square root of 3 first in mine, times parenthesis 1 minus x squared, close, comma, -1, oh, no, I gotta type in x, -1 to 1, and I get 2.3094. It's 4 square root of 3 over 3, but 2.309, so there it is. I know you could have probably done that on your own without me telling you, but sorry. All right, here we go. Let's see if we can speed it up a little bit. Find the number c on the interval 1 to 3 for which f of c is equal to the average value of fx on this interval. Okay, so they want the average value, guys. So 1 over 3 minus 1 integral from 1 to 3 of f of x dx. So let's see what I get. Integral 10x minus 5x squared, comma x, comma 1, comma 3. And I get that, and I got to divide that by 2. So I get a -5 over 3. Let me know if I'm wrong, guys. And it says find the number c for which f of c is equal to that. So type this into y1, and then type this into y2, and see where they equal each other. So I'm going to do that. I'm going to use the solve feature on my calculator here. 10x minus 5x squared. I don't want that to equal -5/3, comma solve for x. And I get -0.15, so I don't want the negative one, I want the positive one. 2.1547. So I get x equals 2.1547. There you go. Suppose that the function f is differentiable and that f of 0 is 2 and f prime equals that. Give the maximum value of f between for x greater than 0. Okay, this is pretty simple, guys. Give the maximum value of f. So first you got to type this into y1 and see where it changes from positive to negative, where f prime changes from positive to negative. So first let's do that. So I'm going to type that into my y1. Square root of x to the 4th plus 3 outside the square root minus, let's see, x cubed over 4, x to the 3rd power divided by 4. Let's see, did I do it? Yeah, I did. All right, window. Let's see, it says for all values that are positive. So I'm going to go from 0. Suppose that the function f is differential, f of 0 is 2. For give the maximum value. Okay, I'm going to start small from 0 to 5, and I'm going to hover around the x-axis, guys. -0.5 to 0.5. And I'm hoping that it changes pretty quickly. I don't see it yet. There we go. Okay, so it does cross from positive to negative pretty quickly. I use this window in case you're wondering. I use x-min 0, x-max 5, and then I just hovered around the x-axis. So I went y-min -0.5, and I did y-max 0.5, and I saw that it crossed. Let me see where it crossed. F5, 0, lower bound 2.5, upper bound, I'm going to say 5. Mine crossed at 4.02284. So that means I have a maximum at that value. This is where the maximum occurs. That's not the answer. So the answer, my value is this. Value equals f of 0 plus the integral from 0 to 4.02284 of f prime. And I think you guys can take it from there, right, guys? So yeah, let's just save some time, and I think you guys can take it from there. So just type that in, and you'll get your answer. Which of the following is an equation of the tangent line to the graph of f at the point where f prime is 2? All right, so first we're going to have to take a derivative equal to 2, get an x value, and then from there we can get a y value. So let's take a derivative of this. So f prime, let's see, 3 times 4, 12, x plus 4 to the third power times 1. So that equal to 2. So I'm just gonna put that in the calculator, guys. I'm not even gonna bother. Well, I guess we could divide by 12, divide by 12, and then cube root it. No, that's not. I'm just gonna put in the calculator here. So 12 parenthesis x plus 4, close it to the third power, and that equals 2. Equals 2, comma x. Okay, I got. Sorry, that took longer than necessary. I got an x value of negative 3.44968. So that's my x value. Type that in here to get a y value. You already know you have to have a slope of 2, right? So that's out, that's out. It has to be one of these three. So I'm going to type in that x value in to get my y value. So let me go back to my home screen here, and I'm going to go 3 parenthesis xc plus 4, close it to the 4th power, plus 2. Oops. Negative 3.444968. Okay, I got a y value of 2.27516. So let's see. Y minus 2.27516 equals 2x plus 3.44968. So I get y equals 2x. 2 times that. So let's see. 2 times 3.44968. And then I'm going to add 2.27516. So I get 2x plus 9.17452. Okay, let's keep going, guys. Oh, that was the last one. Yay! All right. I hope this helps. And I guess I'll see you guys Monday, guys. All right, later. Bye.